Okay.
Don't worry, I have fun for you.
Hello, folks. So as Justin just said, sorry for the folks on the recording for whom I forgot to start. We're going to talk about testing, so let's do that. So far in CS61A, and CS88 and other classes that you've taken, when you wrote code, how did you know that the code worked? Well, probably how you knew that the code worked is somebody else gave you tests to check if your code worked. So on Project Zero, we gave you tests to check if your code works. In 61A, they gave you a bunch of tests. There was this magical autograder that would tell you if you got the points or not, and that would tell you if your code is correct or not. So today, it's kind of a philosophical lecture. There's not a lot of syntax to memorize or new concepts. But the idea today is to give you the power to figure out whether your code works yourselves without having to rely on us writing an autograder for you. Because if you go in the real world, industry, research, there are no autograders out there. So we have to learn how to write tests and check that our code works without autograders. I will say up front that it's usually very hard, if not impossible, to check if your code is 100% completely correct. There are very rare cases where that's possible. You can write little mathematical proofs to check if your code is correct, but that's a kind of an edge case. Most people don't do that. So even though we can't be completely sure that our code is 100% correct, we can write ourselves some tests that'll give us very strong evidence that it's correct. So that's the philosophy we're going to try to do today. We're going to try to give you the skills to go out in your first project and in the world and code things using this new way. So I'm not going to play the movie for time, but Josh has this movie that he likes to show. It's like a little training montage. So yeah, we'll play it. OK. So see, that's you, right? You're the one in the back, and you're learning how to write tests for the first time. And this is us. We're doing the training montage for you. So you can't do this yet, but by the end of today, you will be able to. That's you, just getting the hang of it. OK, so you get the idea. OK, so to figure out how to write tests and how to debug our programs by ourselves without the help of the magical autograder to help, we're going to need an example. So in past semesters, Josh would use sorting as an example. This semester, tell us what we're doing. What have you subjected me to? Here you go.
All right, so this semester we're going to try something new. All right, so.
What are we doing, Justin?
So I have written some code, and I've written a problem. Perrin, you are not aware of it at this time.
I've never seen it before.
So I have written a problem, and I've written some buggy code. And Perrin is going to use your help to debug the code. You ready? Let's do this.
OK, so should I look at the prompt now? Should we look at the prompt together?
Yes.
All right.
Look at the prompt.
OK.
And go.
So usually when I'm up here, I will sometimes lie to you and say, oh, we're trying this for the first time, but I've done it 5 times before. I am not lying. I have never actually seen this before. So let's read it together. I legitimately need 1 minute to read this, so you can take 1 minute to read it as well. There's a link in the very first slide. The reason why it's not on the slides is because I was not allowed to look at it, so it couldn't be on the slides. So, OK, I'll read it. You can read it with me. So we're going to read, I need to compute the variance. So I need to compute the average. OK, fair enough. And then for each one, item x, I compute x minus the average. Then I square the number. And then I take the average of all the squared differences. And thankfully, I've been given an example, which is nice. So 1, 2, 3, 4. The mean is 2.5. For each number, I subtract 2.5. I square it. I get these 4 numbers. Then I average those. And I get 1.25. This, I'm not calculating that, but I'll take your word that that's the right answer. So this is the function we have to write. OK, are people good with this? Do you need more time to read this? I feel like I sort of got it. OK. All right, if you need more time, the PDF is still there. The link is there. OK, so we're not doing sort anymore. We're going to try this new variance thing for the first time ever. So philosophically, what would we do if this were 61A or CS88? What we would do is we would immediately start writing our variance function. So pretend that this is variance. And we would shove it into the magic autograder. And the autograder would give us this beautiful output that tells us exactly what's wrong with our method and how to fix it. But in the real world, this thing doesn't exist. So we're going to have to write our own tests to check that our variance function, so pretend this doesn't say sort. If you want to see the sort version, Josh has a video, but I'm not going to show it today. So if you're curious, you can check it out. But today, we're going to write our own test variance thing, or test variance test, to check if our code works. Okay, so how do we write tests? I'll show you a couple more slides and then we'll do it from scratch. So one way we could write it, and I'll just blaze through this because this is not what we usually do, is we could start by saying, this is what the expected input, this is what our input is, this is what I wish the output was. So if I was hypothetically sorting, which I would have done in a happier time, then we would take this thing, we'd sort it, this would be the expected output, and then I'd have to somehow like compare if the expected output is the same as what I get when I call sort. So I have to write some ridiculous code like, well, maybe I'll write a for loop and I'll check, are these two arrays equal? And if they're not equal, I have to like write my own little error message. So don't look at this too hard. Don't stare at it too hard because this is annoying. It's tedious to write. And if testing was like this, you would never do it because it's not fun. You have to write these specific test error messages. You have to write this for loop. This is not fun. I don't want to do this. So luckily, we don't have to do this because this kind of code appears in basically every test ever we have to write. We have to check if the expected output is the same as the output that we get from calling our function. And I don't want to write this over and over again with the exact same error messages. That's too tedious. So luckily, instead of writing tests like that, because that's no fun and no one would ever do that, we can use libraries that other people have written. So other people wrote the unit testing libraries. They did all the hard work of coming up with the complicated error messages and the checks and the looping through of arrays. So instead of doing all that ourselves, we're just going to make someone else do it. And there are a bunch of different libraries out there for this. The one that we're going to use is called Truth, which was developed by Google. So we're going to use that. Maybe in past semesters, people use different ones. So if a TA whips out some older code, it might be that. But in any case, let's give it a shot. So we're not going to do sorting anymore, unfortunately. But we'll jump into this code, which I have literally never seen before, and we'll see what's going on. So I'm not going to open the correct one. I'm going to open the testing file. OK, I guess I'll also mention briefly, as you can see, this lecture is going to be completely chaotic and disorganized because I have no idea what's going on, but maybe we'll figure it out together. So one thing I will note at some point, I guess right now, is that, not this, not this. OK, maybe not. No slide for it? OK, that's fine. Like I said, we're winging it. We're live. OK, so instead of writing tests after we write our function, so normally what you might expect you to do is you'd write the function, and you're like, this thing totally worked, and then you'll write your test and see if they work. But a very strange idea, which we'll talk about maybe at the end if we have time, and if I get through this whole ordeal, is instead of checking after we write our code whether it works, I want to do something a little bit strange, which is I'm actually going to check if the code works and write my tests before I even write the code. It's like, whoa, mind blown, what's going on? So the idea here is that before we even write the code, and the code is there, we haven't written it yet, we're actually going to start by writing the tests, and then after we have our tests, then we're going to go and write our code. It's kind of a weird backwards idea, but we're going to try it. OK, so I wish I had a slide for that. I swear I did. Maybe it's this one. OK, so kind of. You can read this if you're interested. Basically, the idea is we're going to write the test first. The test is going to fail because we haven't written the code yet. Then we're going to try to write the code to make the test pass. OK, that's the idea. So how do we write tests? Well, first I should figure out what the function is. Am I allowed to open this file? Variants?
Well, you should probably figure out how you solve this problem.
OK, because the main thing I want to figure out is what the signature is. This is the only one? Yes, I'll zoom in. What do you want me to zoom in on? The PDF, OK.
So I guess first off, how are you planning on solving?
So you want me to talk about like my coding approach or my testing approach? My coding approach. OK. Well, seems like there's a function for me to write here, which is public static double variance. Takes in the array. I mean, I guess I'd write a helper function because I don't want to do everything in one method. So I'd probably write a method that like computes the average, maybe. Because I mean, you gave me 3 steps, so I guess I'll write a helper method for the first one. Maybe I'd put this in a helper method, like subtract the mean and square it. Maybe that goes in a helper method. And then I guess I could use the average method again on my 3rd step. You're looking at me funny, like, what's going on? OK.
I'm not looking at you funny.
OK. So, OK, well, that's, I think, what I would do. So anyway, given that there's a variance function, I guess I'm going to try writing some tests. So what test should I write? Well, I was going to write the one in the example that you gave to me, but it seems like you've already written that. So maybe should we just pretend you didn't write it, and I'll write it? Oh.
No, leave it there so you can like make
fine. OK, well,
tests are not enough to
OK, we'll make new ones. OK, so there's a little bit of syntax here. I don't care if you memorize it because, frankly, it's just not very interesting. So I'll show you the syntax a little bit, but it's just not that interesting. So I'll write public void, and then I'll write the name of the test. So I don't know, test, variance, lecture. OK, great. So let's write a test. So what should our input array be?
Pick some numbers.
I don't know. Don't look at me. I don't know the answers.
1, 2, 3, 4.
Don't we already have 1, 2, 3, 4? That's what I was trying to use earlier. 10, 20, 30, 40. Sure, OK. 10, 20, 30, 40. OK, great. So usually when we write a test, what we do is we'll do two things. So first, we're going to think ourselves without looking at the code. What would a correct answer be? And then we'll call the method that we're going to write, and then see if our method gives the correct answer. So I'll write expected, and I'll write actual, and we'll see if they match. So the answer should be a double, right? OK, so what is the expected answer here? I have no idea. OK, so
125.
is it actually 125?
Yes.
Are you being real, or is this like we're like gonna put in some extra bugs to make it life even harder? OK, so
If I did the math right, it's 125.
OK, I'll take your word for it. So if I did not have Justin here, what I would have done is I probably would have gone into Google and like done the math myself, and I would have gotten probably 125. OK, great. That's what the expected value is. So what's the actual value? Well, the actual value is what would happen if I called the actual method. This is why I want to know what the method actually looks like. So I'll just take a guess. I'm guessing it's in the variance class, not the correct one. I'm guessing it's the variance function, and I guess I pass it an input. OK. So normally, you'd be able to open this file and see what the method signature is, but I guess I'm not allowed to, so I won't. OK, great. And then finally, I should check if the value is equal. So this is the part where we're going to use the truth library. So it's already been helpfully imported for me. I don't really care about the import statements. You can just leave them up there. So I'll write something like, assert that. And the nice thing about Google Truth, I guess I'll briefly mention, is that it kind of reads like English. So it's almost like I'm writing an English sentence, which is kind of nice. So even if you don't remember the exact syntax, sometimes you can just guess your way through it, which is what I often do. So I kind of want to check if actual and expected are the same. So maybe I'll just say assert that actual is equal to expected. That's really nice, because now I don't have to manually write my own error message. I don't have to manually check if they're equal. So this statement will check if they're equal for me and also helpfully print out an error message if it's wrong, which is kind of nice. OK, one little problem is it seems like all the other tests that were written, they have these little run buttons so I can run the tests like you were doing in Project Zero. There's no run button here, so what do I do? So one possible idea is I could write a main method, and then in my main method, I could call my test variance. But that's a little annoying, and it's not what you did in the project. So instead, I'm not going to describe how it's done or how this works under the hood. You can check out the extra videos if you're curious. But I'm going to add this funny new syntax, which is just at test. I think that's the one I want. OK, maybe not. At test. Does it work? OK, great. And so what this will do is somehow, for reasons that I haven't explained, it will magically put a run symbol here. And that's going to let me run this test. How does that work? Not terribly important right now. But if you put in the magic words, you'll have this nice little test that you can run. OK, should we write more tests to be confident? Maybe we should. Maybe we shouldn't. Does anyone have questions about what we're doing, about why we're doing this? Yeah.
For doubles, how much floating point error should we account for?
Yeah, that's a great question. It's not one I don't have the answer to because I've never seen this code.
If you want to account for floating point error, go to the bottom.
OK, there was a question about what if the numbers are just like slightly off by like 0.0001. Apparently, Google Truth has some syntax. I'm not going to read that, but I guess you can do assert that output is within a little bit of off by some range of this big number. OK, sounds good. Exciting. So yeah, Google Truth has lots of different features. You're not going to use all of them, just a small subset. For today, it seems like is equal to will do most of the job for us. Should we write more tests? Should we launch into the debugging? Edge cases, that's a good point. So maybe sometimes when we write functions, some of the inputs are weird. So maybe this is like a normal-ish input. Are there any like weird inputs that we have to deal with, perhaps, that we should think about? Sorry, say it one more time. I have no idea who said what.
Oh, like empty list?
Empty list. OK, sure, let's do that. So maybe I'll give this a more descriptive name this time. So test empty list. So I think that's valid syntax, empty list. OK. So the expected value, what is the expected behavior? I don't know. I'll check my spec. Does the spec tell me what to do if I get an empty list?
Yes.
Hello? Hello? At the very bottom. Ah, it does. Okay, so I just can't read. So it returns the variance of that list for 0 if the array has length 0. Aha. So that tells me that the expected should be 0. That tells me that, what's the actual? The actual would be what happens if I actually call the variance function. Okay. And then I can just do the same assert statement as before. Okay. Is equal to, okay, expected. Great. Any other weird edge cases I should deal with before I? The numbers are repeated. I like that one. Let's do that. Okay. What number should I use? As you can see, I'm totally winging this. I have no idea what's going on. Okay. What number should I use? Perhaps I'll just copy paste because I'm lazy. 61. Okay. Is that good? What's the variance? I think it's 0. Okay, great. And if I wasn't sure, what would I do? I'd just go into a calculator and do all this math, which I'm not going to do. But apparently it's 0. Anything else you want to try? Negative numbers. You're really testing me now. Okay. So you're testing the function, which is good. Okay. Let's do test negative. What negative number should we use? Don't look at me. I don't have the answers. Negative 8. Okay.
Oh, no.
There's a plot twist at the end. Okay. Aha, you're on the spot now. Not me anymore.
Hang on.
Let's calculate. Quickly, quickly, or else I'm going to beat you. -1, -2. Should I click it? I don't know what sample and I don't know what sample and population are. I don't remember any of this stuff. This is n-1. That's not what I want. That's not.
29 over 4, I think.
29 over 4. Look at that. Okay. 7.25? Ooh, okay. 7.25. You cheated. You cheated. Okay. You cheated. Okay, that's fine. I cheated too. Okay. I could even cite my sources if I wanted to. Okay. Anything else? Oops. Yeah. Anything else?
Cite your sources.
Just in case.
How about you test average alone?
I'll do one more. Yeah, that's a good point. I didn't know that you had an average method. That's why I didn't test it. But if you have an average method, then I'll certainly try and test it. So what should I test average with?
There's an average test already there.
I see. You gave me the hint. OK. So what should I test average with? Any edge cases, thoughts? 0? Sure. So same thing I'll do. And yeah, I guess it's a little bit tedious sometimes, but that's kind of how testing goes. So just 0 by itself? I want to confirm that's what you want? OK. Expected equals 0, because the average of 0 is 0. OK.
Average, not variance.
OK, average.
You'll still get the right.
I will still get the right answer, sure. OK. And then I'll just copy this little equal of actual and expected. OK. I'll write maybe like 2 more, and then we should get going, because I don't know how long this debugging is going to take me. What else do you want? Empty. OK. I have no clue what the average method is supposed to do when it's empty, though.
What do you want it to?
I don't know. You wrote the method. OK. Sure. I'm going to pretend it's going to return. Should it return 0? I don't know. I guess I'll have it return 0, because I feel like it. We'll see what happens. OK. Anything else? No more? One more? Should we just write like a, what did you want?
Repeated.
Oh, yeah, repeated, sure. What should we do? Like that? OK. I hope the average.
Let's add some numbers that are not repeated.
You want to make it hard? OK, what should I add? Go, calculate. No, OK. I'm not going to do that. Okay. Wait, what number do you want?
Add an extra 5. That would have actually been feasible.
OK, how's that? OK. That's more doable? More? OK.
Change that number to.
You want me to change it? I'll change it.
Change that number to 23.
23? OK, if you say so, boss.
Yeah. Expected should be 7.
7? Oh, OK, because it's clean. All right, sure. OK, I like it. OK, should we check that some of the doubles, because all the doubles we've checked it are like not, they're all 0.0? Maybe we should check one that's not 0.0?
Yeah, all these are integers. Right?
OK, because maybe there's some little error with like integers and not integers that you snuck in there to get me, but I see your game. I'm not going to let you check that. So I'm not going to let you get away with that. So what if this was 24? And this would no longer be 7.0, right? 4, 5, 6, 7, 8, 9. Oh, that's too many. Okay. What about like that? Now it's like 7.125? 25?
35, 24, 59 over 8.
So it's 125?
7,
No, it's
375,
375. Okay, sure.
I think.
What do you mean you think? Okay, I'll check.
When I do mental math, I'm guessing there's
That
like
is true.
6% chance I'm wrong.
All right, let's find out. It's, yeah, 375. Okay, great. So this will also test that not all of my numbers are ending in 0. So again, this is not really like a science. There's no right answer. It's more like an art. So we had to go through and think about edge cases ourselves. You thought of some great ones like empty and repeated. I thought of one which was these all end in point 0. What if they don't end in point 0? And sometimes coming up with these is a little tricky, but it seems like we have something going. Are we good to start?
There's one other edge case I would personally do.
Yeah, what do you want to do? Input having non, that's a good point. So in the same way that we've had, that I just came up with one where it doesn't end in point 0, what if the inputs don't end in point 0? That's a good one, we should do that. So let's do it for both average and maybe also variance. Okay, well, this will be some fun math. Okay, so you want the input to not be integers. So maybe we do like 5.5 and 6.5?
Yeah.
Not too complicated, okay. I would hope the average of that is 6. Great. Maybe let's do one for variance too? Okay, so what should I do? Test, average, repeated. Okay, I guess I'll borrow this one.
Actually, 1.5, 2.5, 3.5, 4.5.
You want 1.5, 2.5, 3.5? Okay, sure, let's do that.
I don't want to do the math harder.
Sure. Okay. So what's the variance of this one? 1.25. All right, if you say so. Okay, cool. So now we have a little bit of extra checks. Variance, okay. Okay.
No, call it variance.
Oh, I see, yeah. Okay,
Gotta have your names right, too.
true, okay. Okay, looks good. So we wrote a bunch of tests, and crucially, we did so before we even wrote any line of code. And so that's the key idea. You don't have to use this idea, but I find it really nice because it means before you even start writing the code, you've already gone through all the thinking of like, oh, you gotta be really careful because these might not be integers, and be really careful because these aren't integers. And oh, by writing these tests, I also kind of realized, hey, maybe I need an average method. So somehow by writing these tests before even jumping into the code, I got a better idea of how to write my code. That's kind of cool. Okay, so I believe now's the moment of truth, and we should run all these tests with the code that we haven't written yet and see if it works.
Yeah.
Yes, I can click this?
Yes.
They're gonna like
technically
explode?
so I think one of them passes.
Okay, that's fine. But the idea is that technically the code is blank. We haven't done anything yet. You and I haven't done anything yet. So we're gonna run it, and unsurprisingly, most of the things we wrote didn't pass. Not too surprising. Okay, so I also have the slide for this. I just don't know where it is anymore. Where's my slide? Here, this is the one I want to tell you about. So we already saw the syntax is to add the word @test. That will somehow magically make the run button appear. More details in the bonus videos if you care. But one thing that I find really cool at this point is that now the process of debugging and making this broken code work, it kind of becomes like a game. So as opposed to just you writing code with no goal, as humans, we like having goals to strive toward. So something I find really nice about IntelliJ in particular is that now we have this list and see all these like X's, and I'm like, I want the X's to go away. And as I change my code, I'm going to slowly make these X's go away, and I know that if they all show up as checks, then I win. And it might feel philosophically kind of like a small thing, but this is the kind of thing that we can use to, I don't know, motivate ourselves, give ourselves clear goals as to what to do next, because sometimes figuring out what to do next is kind of hard. This is why people. Zoomchat found a bug in one of the tests.
Go to test, I think, empty list.
Empty list, yeah. This one?
Yeah, or go to test average empty.
Test average empty. Yeah, what about it?
Never mind. It's that.
Wow, okay. Wow, thanks a lot, Zoom. Okay.
They were saying that there was a variance, but there should be a variance, not an average.
Well, to be fair, I'm switching back and forth a lot, so I can't blame them.
I can't see that. I didn't see it there.
That's all right. Okay. As I was saying, I find it really nice that now there's like this little game you can play where there's a lot of X's and you got to make them all check marks and you win. Maybe that's why we're also addicted to like video games, because it's like, I don't know what do the kids play these days? I don't know. Genshin Impact. I don't know. I have no idea what that is, but people just tell me about it.
We're butt shooting right now.
Yeah, so people are just like, oh, you attack the wizard and you get the magic coin or whatever, right? And this is kind of the same idea, right? You like attack all these little X's, you get the magic check marks, Okay. Is it very obvious I have no idea how to play Genshin Impact? Okay. Excellent. So, I have no idea what any of this stuff is. Out of my depth. Okay. Okay, so with the idea in mind that we want to make all these x's go away, it's time to actually run our tests. We already saw that they failed, so now it's actually time to go in and write our method. So remember, the idea behind test-driven development, as people call it, is we write the tests first. As expected, they mostly fail. Then we go into our method and write it, armed with the extra knowledge that we have. So normally, I'd write it myself, but in the interest of keeping things chaotic,
You know that thing where, someone like bakes a cake on a game show or like TV show, and then like they immediately show a newly baked cake?
not really, but okay. So this is like one of those baking shows where you just watch them on TV, make food,
Like
and present it to you.
Like they show, okay, you mix the cake batter and then you put it in the oven for 3 hours. But we don't have 3 hours, so here's a new cake.
Oh, one of those. Yeah. So on those cooking
We
shows,
don't
they're
have
like,
3 hours, so
yeah,
here's
we
the
put it in the oven, and then we're like, that takes too long, so we'll just get the new cake out. Okay. So,
here's the new code.
all right. So this is the new code. Okay. So I've never seen this before. I'm seeing it for the first time as you are. So we'll inspect it, and immediately we see tons of stuff failed. So I'll try my best to talk through it. Sometimes I might just like stare at it aimlessly if I'm truly stuck. But I will say, one strategy that I find kind of useful is I like solving these one by one. So sometimes it's tempting to be like, oh, there's so many x's, there's so many things I have to handle. So maybe instead of doing all of them at once, I'm going to pick one that I find pretty easy. I'll tackle the easy one first and hope that fixing the easy one causes all of the harder ones to fix themselves. Is that actually going to happen? I don't know, but it would certainly be nice if it did. So let's go through. Do any of the tests seem particularly easy that you'd like to take a shot at first? Empty list seems pretty easy. All right, let's do that. So what did empty list do? It took in an empty list. It wanted the output to be 0. Let's go check. So how should I do that? Well, I could just stare at the code really hard and try to figure it out. But in the interest of actually trying to finish today, I'm going to use the debug feature, which we've seen before. Okay, so I hit debug. Nothing happened. It's still divided by 0 error. Why is that? Well, first it's because I haven't set a breakpoint yet, so I should probably do that. Maybe before even setting the breakpoint, I look at this and I'm like, wait a minute, the code crashed. And if the code crashed, it means I get a traceback. And what does the traceback tell me? It tells me where did the error happen? It happened right here when I called variance. And then this variance called line 13, which called average, and that called line 9, and here's where the crash is. So the traceback has already told me you're dividing by 0 right here. That's kind of nice. So the traceback tells me something is wrong here. So I'm going to set a breakpoint right there because the traceback is telling me your problem is right there. Go check it out. OK, so let's do it. Let's debug. And the program teleports here. And so what do I do in the debugger? Again, it's more art than science. I can look through the things that I'm passing in. And what do I notice? I'm passing in an empty array, which kind of makes sense. That's what I passed in here. It's empty. I can see sum is 0. And then at this point, I'm trying to divide by nums.lane. Aha, that's 0. So I think I'm going to fix this by adding a special case. Maybe, sort of. OK. And maybe I'll just return 0. Seems reasonable. OK. So I made a change. I could debug again. I should do what? I should put it at the start. Does it really matter? OK. Well, if it doesn't matter, I'll leave it as I wrote it. So it's authentic. It's live. OK. So I tried it again. So I got the test from failing to passing, which is nice. It's great. But hold on, there's only one. I have like 9 more to go. So I'll run all the tests again. And hopefully, by solving that one tricky one, I knocked out a bunch. So maybe you remember from earlier, I was passing like 3 of 13 or something. Now I'm passing 5, which is good, right? I'm like Genshin impacting. I don't know what this is. OK. OK, great. So I have more failures to go. So I still have to keep playing this game and make some of these x's go away. So which one do you want to tackle next? And again, you got to pick one that's, I like picking the easy ones. If you want to, you could go tackle this like ridiculous one. But I'm not going to do that because that seems hard. So what do you want to do next? Test negative. Yeah, let's do that. OK, which one is test negative? Oh, you don't want to test negative? OK. Well, that's actually not a bad idea, which is maybe before we even get variance working, maybe we should make sure average is good. Because remember, we wrote a lot of tests for our helper method average. And we know that variance relies on average. That's a good idea. Maybe we should make our average test work first, because some of these averages are not coming out right. That's a good point. So which average one should we do? Let's not do any of the ridiculously hard ones. How many averages do we have? We have this one is failing, this one is failing. Preference, no preference. I'll do output not integers because I felt like it. And again, there's no right answer. If you did the other one, things would still be okay. Okay, so yet again, I find myself in the average function, or we find ourselves because we're doing it together. So at this point, I can start looking inside. And remember, debugging is kind of the art of checking what actually happened and what you expected to happen. So I stop right here, and based on my knowledge of averages and stuff, I think sum should probably be the sum of all this stuff. And I think nums.length should be however long this is. So let's check if they match what I expect. I guess I could also check that this array matches the input. I feel pretty confident that it does. Actually, do I feel confident? Maybe you're like trolling me. OK, it matches? OK, thank you. OK, so I can check. Well, how many things here? 1, 2, 3, 4, 5, 6, 7, 8. Is that 8? 1, 2, 3, 4. Counting on up here is hard. What about the sum? 5, 10, 15, 20, 25, 30, 35, 45, 55, 59.
Yep.
OK, interesting. So what that tells me, and this is also a nice little debugging tip, is because I'm setting breakpoints, I can also separate out where did the bug happen. Did it happen after what's happening, the line right now, or before the line right now? So at first, I didn't say this out loud because I thought I was going to like cleverly find it. I thought you were going to like screw up the for loop and be like, aha, there's like a little off by 1 here or something. So that was my first hypothesis. But why am I able to rule out that hypothesis? Because initially my guess was like, oh, you probably like messed me up by making this for loop wrong. You probably just made this like a 1 or something. I didn't know, but that's what I thought. The reason why I can rule that out is because I stopped right here, and at this point in the code, sums is correct, nums.length is correct, and this array is correct. So everything at this point matches what I expect. So even if I have no idea what this for loop is doing and I just can't even read this code, I feel pretty good that like this is doing what I expect, which is kind of nice. Okay, so I'm pretty confident that the sum is correct. I'm pretty confident that nums.length is correct. So the error must happen either on this line or from something that like set up this line. So maybe I'll step over this line to see what happened. That's one idea. Another idea is maybe if I don't want to step over this line, I could just write it in the box. So remember, this box lets you evaluate stuff, so I can evaluate, hey, what's the value of sum? It's 59. What's the value of sum divided by nums.length? It's 7. So this function is going to return 7. That also matches the error message from earlier. What's the expected? What is it supposed to be? It's not supposed to be 7. It's supposed to be 7.375. Aha, so writing this test was useful because it was 7, but it's actually 7.375. So I look, I actually don't know how to, I feel like I see it. I don't know if anyone else sees it, but I don't know how to like illustrate it further besides just like stopping here and realizing that it's 59, that the sum is correct and the nums.length is correct, but the division output is wrong. So I've narrowed it down, I feel like. Yeah, I think you have the same issue I do, which is that this is an integer. And when I take an integer and I divide it by another integer, I get an integer. OK, so you and I have the same thought, which is good. It means I'm not going crazy up here. So there's a couple thoughts. One thought was I could just like, hey, Java, please pretend this is a double. I'm going to try maybe something like this. What if I make this a double? I feel like that's OK, too. OK, so let's try that. OK, so I'll stop. Unexpected error. I did not expect this to happen. OK, what does it want? It says required int but provided double. So this is a syntax error. It's not even letting me run the code. And it seems to me like what's happening is, aha, the function wants an int, but I want it to return double. More syntax error. So I'm going to go down here. This needs to be a double. OK, so I'm catching your bugs. OK, technically they're my own bugs if we pretend this is me coding, but that's OK. OK, so we'll run the test again, see if anything changed. I feel pretty good about the average now. But I still don't feel very good about thank you for whoever caught that, by the way. Applause for whoever caught that. OK. We're making progress. How much time do I have? 16 minutes. OK. Yeah, I know I have to keep going. OK, so now we're at, what, like 7 passed, 6 failed? OK, so we still have more to do. I think they're all variance ones now. Yep. OK. This is also why it's sometimes nice to write actual, variable names, but whatever. OK, or actual like descriptive test names, but whatever. OK, what should we do next? Don't do big test. Anything else? Test variance? I think this one seems reasonable. Test variance. Test variance. OK, so I can just check what it is. In case you forgot, test variance. Where is test variance? test variance. Okay, there it is. Okay, so this is one of the ones that we had from the start. It's 1, 2, 3, 4. We think the output should be 1.25. I agree. Let's test this. So let's go unset the average breakpoint because we feel pretty good about average now. Why do we feel so good about average even though we didn't have an autograder? Because we wrote our own test and they worked. Okay, so let's do test variance. And this time it's a little bit trickier. I have no clue. I have not even looked at variance before. So I have no clue what's gonna go wrong. So maybe I'll just set a breakpoint inside test variance itself, and I'll just go through line by line until I find something. Maybe I'll find something, maybe I won't. Maybe I'll learn something. So at this point, I'm at variance.variance. Remember your little debugging buttons. I could step over, but if I step over, I'm going to skip all of the variance function executing. So instead, I want to step into the variance function to see what's going on. So I'd find myself in the variance function. Great. What can I do now? I could step into the average function to watch it run, but I feel pretty good about the average function. So maybe I'll just be bold and I'll step over and I'll be like, average, I don't care what's happening inside of you. I feel like I already spent enough time on the average, so I'll skip over you. And something nice is the debugger tells me A is equal to 2.5. And I can even check right now, does 2.5 match what I expect the average to be? I don't know. Let me use my handy dandy built-in calculator. Okay, so I want this divided by 4. Okay, it's 2.5. Thank you, Java. So I feel pretty good about A. Whatever this is, I think that's the right number. Okay, let's keep going. The next line is this. I step over, and I get this new array. And again, the debugger shows it to me. It's got an array. It's got nums.length, which I guess is 4 elements. There they are. They're all zeros. Okay, good. Let's keep going. Here's a loop. Okay, so maybe I'll step into the loop. So double difference equals num sub I plus A. Okay, there's the difference. So where's the difference? It's 3.5. Okay, I feel like this difference is not what I expected. Does anyone else feel the same? I could be totally wrong, by the way. So I'm kind of relying on you to tell me. Does anyone on Zoom? Someone said, why are we adding? That's my question. Why are we adding? What does Zoom think? Are we adding? I don't know. They're still on the return type? Oh, OK. It's like time zone difference. OK. Tape delay. OK. I feel like this should not be add, because you called it difference. I feel like this should be, do people agree with me? I don't know. Yes? OK, we'll make it subtract. If I'm wrong, I blame you. OK, so let's make it subtract. So if I'm feeling bold, I could just run the test to see what happens. Maybe the output will change. I could also set the debugger again. Maybe I'll do that. OK, so let's go back. Let's debug. Having fun yet? OK, so I'll step in. I step in. I step in. OK, so with the plus and minus error fixed, we should now have these numbers each subtracted, or 2.5 should be subtracted from each of these numbers. Is that right? I feel like it is. Where's my spec? Sometimes when in doubt, by the way, read the spec because you might miss stuff. So yeah, it seems like we want to take all the numbers, 1, 2, 3, 4, subtract 2.5. This spec helpfully tells me that I should expect to see 2.25, 0.25, 0.25, 2.25. So I can even write down those numbers and be like, aha, those are the numbers that I want to pop out of this difference variable. So actually, let me just check that. So maybe what I'll do is I'll set a breakpoint here, and then I'll step over the breakpoint, and I'll see what was the value of difference. It was negative 1.5. OK, that's what I want, right? It's negative 1.5. That's the difference because I haven't squared it yet. And what if I want to come back to this breakpoint? I could just mash the step button until I get back, or I can use my magic little continue button to keep running this program until it gets back to the same breakpoint. This time, when I'm back at this breakpoint, I is equal to 1. It's the next for loop iteration. Num sub I is now 2 because it's the next number down. A, I hope, is still 2.5. It is. So if I step over, the difference is negative 0.5. There it is. I can do it again. I step over. Difference is 0.5. There it is. And the last one, I think, was 1.5. OK, great. So I feel pretty good about this double difference. Whatever the heck it's doing, it seems to be getting these 4 numbers out. So again, I'm sort of like, if you build like a timeline, like a movie of what's going on, I feel like if I'm watching the movie, everything is good up until line 19, and I still have to check these lines that come after. So I'm feeling pretty good. OK, so what comes next? Well, now it seems like I'm trying to fill in the square differences. OK, so I'm not going to lie. I expected a specific bug that you would enter into this function, and is not there. And now I feel betrayed. OK, so that's fine. So you did this on purpose. OK. OK, that's fine. So I was expecting a specific bug here, and I was going to be like, oh, I'm so smart, I caught it. But it's not there. OK, so I guess I have to try. So what should I do? I feel like I feel pretty good about the differences. So maybe I'll start over. Maybe I'll start debugging at difference again. OK, maybe the whole thing works, and I just don't know. Maybe should I just run the test to be sure? I have 10 minutes. OK, maybe I'll just run the tests. Ah, they don't all work. OK, but we got close. And unfortunately, only the big test is wrong, the one I really didn't want to write. OK, I was expecting the difference thing to not work. Seems like it did. So, but if it didn't work, what I would do is I would set a breakpoint here, and I would check that this is filling in the right values. Luckily, I didn't have to, but now I have 10 minutes to tackle this one. I feel like this one's going to be annoying. OK, so let's do it. That's fine. Sometimes that happens, right? Sometimes the test you write is just annoying, and it's hard to find. It could also, sometimes if you don't want to debug this, we could write more tests that are not this one to try to get it to fail on one that's not as annoyingly large as this one. That's also a possibility. Don't tell me the test itself is wrong. I feel like it might be, but it might not be. OK, what should I do? Does anyone have ideas? Help me out. You're like leaving me out to dry alone. So I guess because I don't know what's going on, maybe I'll just like set the breakpoint here, and I'll go through. And if anyone has inspiration, please tell me, because I actually don't have any at this point. And I have 10 minutes left. OK. And if I don't get it, I'm going to have to like ask you for the answer in shame, and I don't want to do that. OK, so what should I do? OK, input size is 1,000. I feel pretty good about that. I have this array of 1,000, which I feel pretty good about. This I equals 1 is really messing me up, though. I don't like this I equals 1. Let's see. But you want the first 1,000 cubes. So I know that the first 3 numbers should be 1, 8, and 27. You told me this was fine before lecture, but I don't trust you, so I'm going to check. OK, so input is 2. Wait a minute. You told me this was fine. What the heck? OK. OK, so this should be 1. But there's 2 here. So I found the difference between what was expected and what actually happened. Aha. I know your tricks now. OK, right? Here, I was told that this test was probably doing something with the first 1,000 cubes, which were 1, 8, and 27. Here, I can see that they are not, because this number is 2. And I bet if I keep going, they're going to be more. OK, that's not right, because that should be 8. OK. OK, that's not right. That's 0. That's 7. OK, so none of these are right. These are not the cubes of the numbers. OK, so I don't feel good about this. OK, so something about the test is wrong. And unfortunately, that's something that happens sometimes. Sometimes your function is good, but the test itself is wrong. And sometimes we just have to deal with that, and it's kind of annoying. But at least we've narrowed it down a little bit. So could the error be on this line? Oops. Could the error be on this assert line? It could. But I feel like if I'm like watching the movie play, I feel like something has already gone wrong here. And because something has already gone wrong here, I don't really care whether this is right or not. It could be wrong. I'll check it later. But I've already figured out that something is wrong around this loop. So I should probably start checking around here. OK, so what should I do? I still don't feel comfortable about this like I equals 1, and then this being I minus 1, and this being I. That feels kind of weird to me. So maybe I'll check that. Is there anything else that people noticed? I don't know. Let's keep checking. Because the numbers are still like totally off, too. Like, it's not like they're cube numbers, and they're just kind of off. OK, so I step into here. You want me to use times? OK, well, hold on. So that's not a bad idea. Maybe use times. I'm going to check one thing just because I'm not sure. So this input is 0. And then in 0, I'm putting I, which is 1. So I feel pretty good about that. And how do I know? Because I is 1. I'm putting something in input 0. The next time around, I is equal to 2. I'm putting something in input 1. So I feel pretty good about the indexing, although it looked kind of strange at first. Someone said something about like POW or something. Tell me.
Let's Google it.
You want me to Google it? OK, I'll Google. I've done so much Googling today. But Google's your friend, though. As long as you set your sources, it's totally OK. What should I Google? OK, like this. Operators in Java. I disabled my ad blocker. I disabled, OK, hold on, where's it? I don't want to support you. OK, so this thing. D and E, OK. I don't know what any of this stuff means. I don't know what this is, but it's definitely not power. I don't know about you. I don't feel like this is power? This is not power. OK. All right. So what do I do next? How to power, okay. I don't know, okay. Math.pow, thank you, Google, okay. I can even cite if I wanted to. Does Java have an exponential? No. Okay, math.pow. Okay, so I used u. So where's my source? Okay. I used this. Great, I cited it. I have 5 minutes to fix this. Okay, what did I use? Math.pow. I actually don't know what the argument order is. Is it, I'm guessing this is the base and this is the exponent, so it's 2 to the 3. This is 3 to the 2, okay. So I want I to the 3. So I want math.pow I cubed. I feel pretty good about that. Okay. The import is there. I feel pretty, I guess there's no import needed. Okay, I feel better about that. I'll use the debugger to double check. Let's hope. Okay. If this is wrong, I'm gonna have to beg your forgiveness. Okay, so this time, I'm expecting the number 1 to show up here, so I step over. It's 1, feeling pretty good. This time, I'm calling math.pow on I is equal to 2, 2 cubed, that better be 8. Okay, so is that right? Got me up here. I don't even know my cube numbers anymore. Okay, so it's 8. The next one is 27. The next one is 64. Okay, so I feel pretty good about this. I have no idea if this number is correct. I'll have to take your word that this number is correct. It's right there, 8.06 times 10 to the 16. Okay, okay. So with 4 minutes left, if there's another bug after this, I am so screwed. You don't even know. Okay. I mean, you're not screwed because you have extra time, right? You're not doing this on like a 1 hour clock. Well, yeah, you got to be paranoid when you're debugging. Okay, so I'll not get some. Okay, everybody cross the fingers. Don't breathe. I hope this works. Oh, okay. Whew. Okay. Thank you, everybody. Thank you for catching that. Okay. But wait, that was only one of the tests. I should check the other ones too. If all of these other ones work, you can go home 3 minutes early. So everybody pray. Okay, go home. Okay. Hold on. I'm sorry. I have one more slide, so maybe you don't go just yet. Final slide really quickly. If you're curious, they're at the end. I shouldn't have been so hasty, but there's also an extra video if you're curious. Basically, what we do not recommend, do not spam the autograder to check if your code is correct. The autograder is limited. It will not let you spam the autograder. So we don't recommend doing this. It's slow. It doesn't work. It doesn't let you figure out what's going on. Oops. So try doing what we just did, which is write the test ahead of time, invest time early, will save you time in the long run. Oh, I shouldn't have let people go at the end. Okay, well, we figured it out. So those are the videos. Okay, okay, no more, we're never doing this again. Okay,